and thank you for attending today's webinar on Life Safety Dampers Part 2, presented by Ruskin product experts Mike Collazo and Spencer Brinkmeyer. The webinar today will be approximately 45 minutes long, followed by a Q&A session. If you have any questions during the webinar, please use the box in the upper right corner of your screen to submit them. All questions will remain anonymous and will only be seen by the presenter. If we do not get to all questions, we will send out the answers after this presentation. At the conclusion of today's webinar, you will receive a certificate of attendance, a link to the recording of this presentation, and a registration link to next week's webinar on louver specifications with Jim Smarto. Thank you again for attending, and I will now turn it over to Spencer.
Thank you, Emma. Hi, my name's Spencer Brinkmeyer. I'm a regional sales manager for Ruskin, and we are excited to talk to you about the latest installment of the Ruskin webinar series, Life Safety Dampers Part 2. I'd like to introduce our special primary speaker today, Mike Collazo, who is the commercial damper product manager. However, Mike has, in his 20+ years of experience at Ruskin, spent more time actually focusing on life safety dampers. So he is a guru in this realm and is going to be great to guide us through some of the maintenance considerations and also some specialty type dampers that we're going to be discussing today. I will be asking Mike some questions throughout the presentation. And with that, Mike, please take it away.
All right. Hello, everyone, and thanks, Spencer. Yeah, as Spencer alluded to, many years at Ruskin, I've dealt with the life safety product line, and that means I've dealt with numerous mechanical engineers around the country, architects, building code officials, as well as contractors. So there's a lot of history and job situations that I've been involved with. So hopefully I'll be able to shed light on some of these topics and inform you. So really there's 4 areas I'm going to cover today. What's new in life safety. Then we'll touch on some damper accessories that are common to smoke and fire smoke dampers. And then I'll spend a little bit more time on ceiling dampers. The applications around ceiling dampers can be a little nuanced and problematic, so we'll try to go into some more detail there, and then we'll finish up with the NFPA testing and maintenance. So what's new with life safety dampers? If you're familiar with Ruskin's YouTube channel, we've actually added some more content there in terms of videos. Now on the left-hand side, our SP100 field kit, we don't have that video live just yet, but it will be coming. So our SP100 switch package, that's actually used on control dampers as well. And this is a switch package that allows you to indicate or know the position of your blades, whether they're open or closed. Without a switch package on a damper, there's no way to tell if it's open or closed without physically being at the damper to see it. So the SP100 video is going to show you how to field mount that in the event that you forgot to order it on the damper. And so it's going to walk you through how to mount that in the airstream as well as out of the airstream on the damper. Now to the right, we have our actuator relocation video. That one is live, by the way, so you can actually go view that today. So oftentimes we get calls for the field where somebody's ordered a damper, and because of usually space conditions or other reasons, they need to actually physically relocate that actuator and or heat sensor either out of the airstream or in the airstream, depending on which is the case. So these videos are going to show you exactly how that's done. So it's nice to be able to actually see it in a video type style, opposed to trying to have it described on paper. So I think you'll benefit from that. Another thing that's relatively new that we want to point out is on our fire smoke dampers, anytime you have 2 actuators or 4 or 6 or 8, depending on the size, we actually now will standardly tandem mount these actuators. So just as you see in the images there on the left and right, the tandem mount just means the 2 actuators are essentially piggybacked together. So this is going to be available for in the airstream as well as out of the airstream. And those detail illustrations in the middle there, there's sort of a naming code structure to it. And so we have standard configurations that we would do if you don't say anything. And then we also have optional details that you can choose from if you have a preference. And this document's found on our website. It's going to be under all of the smoke and fire smoke damper models. Some other new models that we have available. Ruskin is the only one at the moment who has the vertical blade modulating smoke and fire smoke dampers. So these three models here, the SD60V M, and then we have in the middle, the SD50 VM, and then to the right, our FSD60 VM. You'll notice that the sizing on the smoke dampers goes up quite a bit larger than the fire smoke damper. Oftentimes, the fire smoke dampers can't always go as large as a smoke damper. So currently, we're just doing a single section on the fire smoke damper. So I just want to make sure you guys understand why there's differences on the sizing. So who cares about vertical blades, right? A lot of times people wonder, why do I need a vertical blade? Well, there's two main reasons. If you have ductwork that's close together, your dampers, if they're horizontal mount and the actuators are on the side of the dampers, you're going to face space problems typically. So the vertical mount allows the motor to be mounted on the top or the bottom of the damper, depending on which way it's installed. Another reason would be for conducive airflow, depending on the arrangement of the damper. One example I'll point out would be like an underfloor system, where you have a modulating damper that's needed to control the air volume. A lot of times the ductwork is going to come vertical and then turn 90. So vertical blades damper, the airflow through that is more conducive than a horizontal blade, where the air would kind of hit the blade at a unpreferable angle, because it's going to hit the blade flat opposed to going through the vertical blade. So that's the other reason. And some other new content that we're adding to our product data submittals is going to be leakage to atmosphere. If you're familiar with the SMACNA requirements on duct leakage, just from the duct to atmosphere, what you're seeing here in these two charts are going to be on the left-hand side is the fire smoke damper, or FSD60. It's going to be a sleeved damper. And then on the right, we have a sleeved IBD2, which is a curtain-style fire damper. The red and green dashed lines that you see in the chart there, those represent the SMACNA requirements for duct leakage to atmosphere, and the blue line at the bottom that's going to represent our damper, a sleeve damper. So what this is telling you is that our sleeve dampers actually have a lower leakage to atmosphere than the SMACNA requirements. So that's a good thing. And so we're going to start putting this information on our life safety products, just so you're aware of what our duct leakage to atmosphere is. And here's another example on a smoke damper. Smoke dampers aren't always sleeved, but this just gives you a understanding that if you order a smoke damper from the factory and it's sleeved, that green line at the bottom represents our sleeved smoke dampers. So once again, we're lower than the leakage to atmosphere for duct that SMACNA requires, and that's the light blue and dark blue lines there. So again, just another benefit when you have factory sleeve dampers. And the last example is going to be really just giving you an understanding of what happens when you order a damper. In this case, on the left, this would be a fire damper that has a squared around transition sleeve, but our style is not sealed at the factory. It's an economical model, sort of intended for the contractor to seal that in the field. But as you'll see there, that blue line at the top has much higher leakage to atmosphere than the SMACNA class leakages at the bottom, which is the red and green dashed lines there. And then to the right, that represents a sleeved fire damper from the factory. And in this case, it's going to be fully sealed. And so you'll see that blue line drops down. So once again, our leakage is improved to atmosphere. And so it just gives you an understanding if you have one model versus the other. So just keep that in mind. Again, contractors can seal dampers in the field, but from the factory, this is what it would look like. Another piece of performance data that we've included in our true round dampers is pressure drop performance. And here what you're seeing is these are just copy and paste from our data sheet, and this is showing the three AMCA configurations, the 5.2, 5.3, and 5.5. Again, we've done extensive testing, just trying to prove out what the pressure drop is across a range of sizes. And so we've added this to the product data sheet just to give you extra performance information.
Hey, Mike, I got a quick question on the true rounds. What are
Sure.
some of the other benefits of the true round damper versus the more traditional squared around?
Sure, no, that's a great question. Well, there's two main benefits. Pressure drop through an actual round object or cylinder is always better than a squared around, just because you have more, the airflow through a squared around is a little more abrupt. So you have the pressure drop just being lower than a squared around. So that's obviously it's a system improvement just to have less pressure drop. On the other side, on the installation side, I should say, you also benefit because true round dampers, i.e. fire damper and fire smoke dampers, are actually easier or faster to install. There's less screw fasteners. Round dampers can be installed in square openings, and they also come with a standard retaining plate for that. So you got pressure drop performance improvement, and then you also have installation, speed of installation. Okay, so let's move on now to rated shaft enclosures. Many of you are familiar with dealing with shafts, and oftentimes you may have run into this particular situation. So what we're showing here, this illustration is essentially showing you what happens at the bottom of a shaft. Typically at the bottom of a shaft, when your duct penetrates through there and you apply dampers, it normally should be a concrete slab opening because that's where dampers are typically located, and that's the listing for them. But if you don't have a concrete poured opening there where the duct penetrates, you're either going to have to build some other sort of rated enclosure that gets approved by the authority having jurisdiction, and that's what this illustration shows. So what they've done here is they've extended the rated shaft below the floor line, and what usually has to happen is that enclosure has to be at least a 2-hour rated construction, but it also is going to be a little more robust than just the shaft wall construction itself. And that's kind of what they're trying to illustrate here. And once that's done, then the duct can be routed out the enclosure wall, and then it gets treated like a standard wall mounted or vertical mounted damper installation. So this is one of the alternatives that engineers resort to when they encounter this situation. But we have another solution. Actually, it's another UL solution, and that'll come up on the next slide. So UL Design I-503 is another solution alternative for the bottom of shaft scenario, and that's what we're showing here. UL, for the first time, has evaluated and approved this 2-hour rated fire protective membrane system. So this would essentially be built in lieu of a poured concrete opening, and so that's what we're illustrating here. You can see that obviously on the left and the right, we're kind of showing you a kind of a section view through the shaft on the left, and then you see a sort of an aerial view on the right side. So this would allow you to apply a fire or fire smoke damper in framed openings in this particular material or construction. It's essentially a wall that's turned on its side, so it's not a floor, it's not a ceiling. It would represent more of a wall type construction, but it's going to be a more robust construction. So just keep I-503 in mind if you have a need for solving your bottom of shaft installations. Okay, we'll move on now to damper accessories. So first up is our what we call a DTS, a damper test switch. These are becoming quite popular, mainly because they make it very easy and quick to test a smoke or combination fire smoke dampers. So damper test switches are interfaced with a motorized damper, because obviously now we're talking about a power supply to the damper. We can supply these built right into the heat sensor for fire smoke dampers, or as a standalone item for a smoke damper, or even a fire smoke damper. We have a standalone version as well. So if the particular code official or engineer prefers a switch to be built right into the heat sensor, it would look like this. And you can see there's a push button there that would momentarily interrupt the power supply as long as you hold your finger on that button. So keep in mind, if you have it on the damper, then you will have to get up on a ladder and you're going to be physically at the damper doing this. If you want to do it remotely, then you would order a different type, which we'll talk about here in a moment, to do the remote mounting. So here we have a variety of other control panels. So let me just kind of walk you through these. I'll start on the left-hand side. So on the left-hand side, we have our MCP1 and 2. These two control panels are only used with our TS150, which you see there in the lower center on the left side there. So a TS150 is a dual heat sensor device. It's intended for smoke management systems. So what happens is you have a primary sensor, which is typically 165 degrees Fahrenheit, and then you have a higher limit sensor, which is either 250 or 350 degrees in most cases. So if you imagine in a fire event, your heat sensor gets tripped on the 165, and now your damper's closed. But if you need to reopen the damper, if the fire department comes in and they're trying to open a damper on a particular floor, because they need to exhaust smoke out, the only way to do that is to override the sensor that tripped and to activate the high limit one. And so what you see on those control panels, or you see a toggle switch, and then there's a key switch, and that's how they're controlling the override of that sensor. So again, these are sort of special, because if you don't have a need for a smoke management system, you'd never use a TS150 or these MCP1 or 2 panels. Now to the right-hand side, we have panels that are just simply for either light indication, or we also have a push test button there, as you see on the far right-hand side. Again, all of these devices, let me back up, I should say all 4 that you see at the top there would all be used with the switch package. That's why they have light indicators. So your switch package would basically give you these light indications as your blades open or close. Now the 2 you see on the bottom right, those are just simply a push to test button. That could be used with a smoke or a fire smoke damper. And again, you don't have lights there, you just have a button to be able to test your damper remotely. And the other accessory I'll talk about is duct smoke detectors. So what you're seeing here is, you have 2 different detectors that we offer. On the left-hand side, we have our flow type detector, as you can see how that's mounted. The flow detectors are always mounted out of the airstream, which is what you're seeing there on the round damper and the square damper. A flow detector works at a velocity of at least 100 feet per minute. And then on the right-hand side, we have a no flow detector. The no flow, just as the name implies, there's 0 velocity required for that to operate. So the no flow is going to be a pendant mount. You can kind of see that there on the interior of the damper sleeve. So we pendant mount that. And one thing I'll point out is that both of these detectors, they're common to the industry. They're considered compatible type detectors. So they'll work with a fire alarm panel, but since they're not addressable, they don't have the same protocol. So the panel can't really talk to the detector. So I just want to point that out. Oftentimes people aren't familiar with addressable versus compatible type. All right, so let's move on into ceiling dampers. So there's a couple different names that people assign to a ceiling fire dampers. Ruskin calls them ceiling fire dampers. Some companies call them ceiling radiation dampers. It means the same thing. The radiation damper sort of gets at the heart of the performance that a ceiling damper has, because it does stop or limit the radiant heat transfer up through the ceiling. And so we'll explore that here in just a moment on the next slide. So under the UL standard 555C, this is what covers ceiling dampers. UL evaluates these in one of 2 ways. The first is they've compared what you see there on the right-hand side. They've compared this current design, which we refer to it as a butterfly blade style. So they've compared or evaluated this damper construction against the hinge door damper. So years ago or decades ago, before these ceiling dampers existed, how they handled air duct penetrations is they essentially just had a piece of sheet metal with ceramic fiber on it, and then there was a fuse link that held that open. So if you had a fire vent, the link would separate, and that hinge door would just come down and sort of blank off the air duct. And so that was sort of old technology. Since then, we have different designs, and so UL's just simply tested this in lieu of the hinge door damper. And since it performs satisfactory or even better in some cases, universally all damper companies can use their ceiling fire dampers in any design that used the old hinge door style. So that's one universal application. The second evaluation is going to be testing the ceiling damper in a specific UL design. Now there's some design number examples shown there at the lower bottom right there, the L501, 528, and P533. Keep in mind that any design that's been tested with UL if it's a roof or floor assembly, they're all assigned a number, and the number is always a letter and then 3 numbers behind it. Just keep that in mind. Okay, so how do ceiling dampers get rated? So they're a little bit different than a standard fire damper, which you all may be familiar with, the 1.5 hour or 3 hour ratings that get assigned to a standard fire damper. So ceiling dampers really just take on the rating of the assembly they're being applied in. So there's no number per se that's going to be on the damper. Even though they can go from 1 to 4 hours, that's really based on the assemblies that are in the UL directory. If it's wood construction, in most cases it's only rated for 1 hour, so the damper is only going to be good for 1 hour. If it's steel joist and concrete and other type of construction, those can go up to, like I said, 3 and 4 hour range. So just bear in mind that the ratings of ceiling dampers are treated a little bit differently. So in the building code in chapter 7, where they deal with the fire protection features, there's a section on horizontal assemblies, and this is really where the ceiling fire dampers come into play. So horizontal assemblies can be anything from a roof ceiling assembly to a floor ceiling assembly, and you see examples here. In the center upper right there, there's a pitch roof design, so that's our roof ceiling assembly example. And then to the left, we have a wood truss floor design, and then to the right, we have a steel joist concrete floor ceiling assembly. So these are just examples of that. If these are in the UL directory, once again, as I said, they'll have a UL design number. But one thing we'll talk about here in the next slide will be proprietary ceiling designs and also unevaluated ceiling designs. So membrane penetrations, and this is key because ceiling radiation dampers are only used in lower membrane penetrations. That's the only place they're ever located. So they're never going to be at the top of the floor line or somewhere in the middle. They're always at the lower membrane. So in this illustration here, I always consider this a by the book ceiling fire damper installation. So to the left there you see there's a furnace unit, and they're ducting off of that up through the drywall, which is the lower membrane of that floor ceiling assembly. So as they duct through there, it's really considered a through penetration because there's no grill or air device. It's really just duct all the way up through there, and then it turns 90 and kind of runs down through that cavity space there. So a radiation damper would go at that location on the left, and it's protecting that penetration. And then as you come off, you have other duct runs that come off into the other ceiling space areas. And in this case, it'd probably be a grill, some sort of an air device. Then the radiation dampers would be applied at those additional openings, and they're going to be usually attached to the neck of that grill or diffuser. And so you have ceiling dampers protecting all of those penetrations. You have to keep in mind these are really solid structures when they're fire tested. So once you penetrate through there with air ducts, now you have to have protection. And so that's where the ceiling radiation damper comes into play. So let's talk about proprietary ceiling design. When we refer to that name proprietary, we're really referring to a design that's owned by a damper company. So it's proprietary to them. In this example here, we have design L521. It is proprietary. It's owned by a single damper company. So what happens oftentimes is an architect may specify various designs on a job without knowing if it's proprietary or not. Sometimes they're not really going that deep into it. They just know they need a wood truss or wood joist design, so they select one. So the call we get is usually asking if our damper is suitable for that particular design. Now, once we know the design number, we can look it up. We can see whose it is, if it is proprietary. And then from there, it's usually going to involve the authority having jurisdiction to make a judgment call on the use of a different product in lieu of the one that the design calls out. You got to keep in mind when you go fire test your product, UL is only going to assign that number to the submitter, and obviously if it's owned by a damper company, they're not going to share that with other companies. So that's why we have proprietary designs. Ruskin has several designs, so every major damper company has designs that are out there that are unique to them. But again, there is going to be some nuance there because, as I said, a lot of times different products show up on the job, and then that's where the discussion picks up from. So I'll kind of give you on the next slide some guidance to how to go about handling that. So the good news is there's multiple designs in the UL directory that are essentially identical to the proprietary ones. And so what we try to do when we have the situation of the proprietary design, we try to point out the other designs that are essentially identical to the proprietary ones. And what we try to do is show the comparisons that the same criteria exist between the proprietary designs and what we'll call the generic designs, or designs that are open to all damper manufacturers. These designs you see here on the lower left-hand side, these are owned by gypsum companies. So there's no damper manufacturer involved. So the gypsum companies will allow all damper companies' products to be on those designs. Now, many times architects may not be aware of that. So that's one of our messages to architects, is to be familiar with the designs that are open. So we consider them generic. Again, if you're dealing with a proprietary design, some code officials may want just that damper model that's called out to be used, and others are open because they start to understand the nature of how designs get tested and the numbers that get assigned to them. So again, it's sort of there is some gray area because it's not black and white. So these are some of the talking points that we get into when you're dealing with jobs that have proprietary designs on them. You'll notice here on these wood truss assemblies, 18 inches is usually the minimum height that's required when you use a damper. There are designs that have shorter heights, like 14 inches, and in those cases, dampers really aren't applicable. And that's another discrepancy that comes up when people are applying dampers in designs that are less than what the requirement is for a damper to be applied. So along with wood truss, we also have wood joists, floor systems. Wood joist systems are usually going to be a 2x10 or 2x12 piece of wood, and you kind of see that here in the images on the left. So a joist system, it's shorter than a truss, and that's just the nature of how they're built. So in this case, we do have dampers applicable for them, but these dampers usually are going to require a thermal blanket that's wrapped on the outside of a steel plenum box, and that's what you're seeing here in these images. Just an example of what that material looks like. So it is supplied from the factory, and then the contractor would just add that material to the plenum box. And this is our model CFD7. Our 7T is for truss, and then we drop the T when it's for a joist system. The nice thing here is that there are 20 different UL designs that this damper is applicable in, so it does cover even a wider range than the wood truss designs. I will say, though, that the wood truss is probably more popular construction throughout the country than the wood joist. And then I also mentioned about unevaluated ceiling assemblies, right? So what does it mean when we say unevaluated? Well, it means they've never been tested with an air duct opening. So that's what you're seeing here. On the left-hand side, this particular design, if you look it up in the UL directory, there's no damper that's called out, and there's no air duct called out. So now this does happen oftentimes where someone is working with the unevaluated design, and then they have air ducts that are needed, so they apply dampers in them. And so that photo in the middle is actually this design, and that's how it's built. It's an I-joist system. So it's essentially wood members that are glued together. Now, this is really more of a misapplication because now they're applying a damper arbitrarily in a untested ceiling assembly. So in this case, it's definitely going to require the authority having jurisdiction, because there's going to be no criteria in this design for how big the damper could be, since it's never been tested. So there's a lot of unknowns here. So the best we could do here is just basically have you consult with the authority having jurisdiction, or AHJ, and then find out what they can, if they're willing to either allow this or if there's other measures that are needed. We have seen in cases where they've had to remove dampers and sort of start the whole process over again, because like I said, no damper company will have a solution for this because there's no damper listed for this design.
Hey, Mike, we seem to get a lot of pictures like this of ceiling fire dampers that have been misapplied. Why do you think there is so much confusion around the correct selection and installation of ceiling fire dampers?
Yeah, no, that's an excellent question. The short answer is that there's a lot of factors that are overlooked up front, meaning either no one's really investigated if that ceiling design either allows for dampers or if it's proprietary. It could be that, or it could just be that there was just sort of a lack of understanding of how dampers get applied. Oftentimes people will unknowingly just think, well, I have a fire damper and I need to protect the opening. So they sort of go into it sort of innocent without knowing there's more behind it. And that's usually the call that we're on, is that we're kind of, we're being asked to now, advise or recommend after they're well into it. And so that's why the AHJ usually is going to be the more important person to consult with, because Ruskin won't have we're not the authority to actually tell them they can use this or that. Now, I will say that at least in this application, that they're choosing the right damper. I mean, a ceiling damper would be more the correct damper. We have seen where they try to use curtain fire dampers, which would completely be a misapplication. But again, to your point, Spencer, there's just a lot of factors involved that are just not being considered, and that's how these situations end up like this. And one thing I'll point out on, and this is the last point I'll make on the ceiling damper topic, is we have a new model that's coming out soon. It's called the CFD7T SR. The SR is for squared around. As you see there in the image on the right, we have a square, essentially a square box with a round collar, and then the ceiling fire damper resides in that round collar. Now, the nice thing here, and again, this is new for us, but we don't have anything like it currently. The nice thing here is that it will lend itself to a more easy grill OBD arrangement, because we have a deeper neck, if you will, in that square transition. So it's going to facilitate a lot more varieties on your grill OBD arrangements. And then, of course, the round duct connection on the top is going to facilitate spiral duct or flex duct. So again, this will be coming out probably more closer to the end of the year. And then we'll also have an R6 duct liner option available as well. So again, we'll talk more about this when it comes out, and we'll put an announcement out as well. Okay, so let's move on to, and this is our last discussion point here, to NFPA. This is damper testing, operation, and maintenance. So NFPA, the National Fire Protection Association, they're actually the authority on the subject of testing and maintaining dampers. In fact, the International Building Code and the International Fire Code, they don't even get into the details of this. They simply just turn it over to NFPA. So again, the codes always refer back to NFPA on the topic of maintenance. And as we walk through these next slides here, I'll point out some of the critical things to be aware of. So first up, we just have some interesting field photos. These aren't Photoshopped. These are actual real photos from the field that we received from various companies that are hired to go in to a lot of times hospitals and find the dampers and try to test and maintain them. So you can see here in these images, we see everything from zip ties trying to hold blades up, to ceiling tile, to cans, you name it. So there's a number of discrepancies that are out there actually in the real world. Do keep in mind that testing dampers can be difficult. In these images here, you're seeing curtain dampers, and then you're seeing some multi-blade dampers. But we'll kind of walk you through an example of just how difficult it is to test a damper. So once they locate the damper and then discover what condition that it's in, then they have to go about testing it as well. So we're going to kind of walk through some examples. So as I mentioned a moment ago, the International Fire Code, this is actually relatively new language that they've put in. And here's that example where I tell you they just basically point back to the NFPA publications, 80 and 105, which cover all the fire and smoke damper products. So testing dampers, as I mentioned, a curtain damper, which you see on the left here. Now this figure that we're showing is up to $500 to basically test and maintain that. So these numbers aren't really coming from Ruskin. These are numbers that actually come from the companies that are hired to go in to test and maintain the dampers in a facility. A curtain damper, the reason why this figure is so elevated is because the difficulty and the burden to try to locate the dampers, oftentimes they're crawling through the ceiling space, they're going through access points, access doors or panels. And there's a lot of time that's spent there just trying to gain access to the damper, remove the fuse link, and investigate any other discrepancies if there are any. So again, this number could go as high as $500 just to test and maintain a single damper. To the right there, when we say as low as $1, I mean we're not exaggerating. A motorized damper is quick and simple to test. It's as simple as pushing that test button that we talked about. All they have to do is interrupt power and then reapply power, and they cycle tested that damper. So that's the dramatic difference between a non-motorized and a motorized damper product on the maintenance side. So in this video here, what I want to just let you know is that this is a small curtain damper. And so what you're going to witness here is a person just trying to remove that fuse link. Now, as you'll see here, this is not an installed damper. It's just sitting on the table. But you'll notice when we start the video, just the difficulty that's involved in trying to take that fuse link off and then reapply it. So just imagine someone on a ladder reaching through an access door, a small access door at that, trying to do the same thing. And then we'll go ahead and see the video. So he's got to bend that strap down just to be able to remove that link off of that particular side before the blades can actually come down. Now he's got to pull those blades back up. In this case, there's no spring tension. This is a static rated damper, so pushing the springs back up was relatively easy, but now he's got to reattach that. And keep in mind, he's got two hands on the damper that you'd never have in the field. You'd never be able to get the ergonomics of your hands on a damper like that. So this kind of puts in perspective of just how difficult just doing it not installed, and then you can imagine when it's installed in Duct. All right, so this next video, we're just going to show the link actually being separated from heat. You wouldn't actually do this necessarily in the field. That's just a demonstration. But in this damper here, it's actually a spring-loaded damper. It's got two what we call negator springs that actually pull the damper blades down with force as high as 40 pounds. And then there's blade catches on the left and right where the blade, as it drops down, it kind of rests inside these grooves to hold it in place. So we'll go ahead and watch that fire test here. You can see just how quickly those springs come down, and that's a result of the just the pressure on the springs. And so trying to reopen this damper is going to be a challenge for anyone. So you can imagine just the difficulty on a spring-loaded dynamic type. So again, I think you understand the point of curtain dampers and just the difficulty. Now on the motorized product side, what you see here, these smoke and fire smoke dampers, like I said, these are all going to be quick and easy to test because it's just a simple remove power and then reapply power, and you've cycle tested the damper. That's what the building code would require in terms of an actual test. Now we talked about the switch package on the damper blade, and here on the next slide we're going to actually get into some other ways of testing the damper to make it a little more easier in the field and for the facility. So we talked earlier about that damper test switch, and really this is sort of an entry level for testing the damper. Obviously, if you didn't have this, then you'd be back to sort of the old-fashioned style of just radioing back to someone at the circuit to drop power while you're on a ladder at the damper, just to kind of hear the motor de-energize or spring return close. But again, a damper test switch, as we mentioned earlier, can be either built in at the damper or can be remote mounted, but this is sort of the entry level. The most basic way to test a damper is through a damper test switch. And then we move up to a master control panel. This gets a little more sophisticated because now we have that same test button, but we also have an open close light indicators, right? So we know that we need the switch package because the switch package wires are what wire back to those two lights there. So this would sort of be a step up from just a simple test damper test switch. This is a damper test switch with light, so you can actually see what's happening. So this could be mounted on a wall, in a closet, or even on the ceiling. And so we'll actually watch this happen in real time. So here's a example of that same control panel with the test switch, and we'll go ahead and play the video, and you can watch how it operates, the functionality. And this is on a round damper. So he's just pushing the momentary test button in. So as long as his finger's on that button, power is interrupted. So we no longer have power to the actuator. So once it loses power, the spring in the motor is going to bring the damper to a closed position, which is what's happening there. So we lost power, the damper actuator sprung closed, and now he released his finger, and we're going to re-energize. and that green light comes on once the switch contact is made. So that's just an example of how it looks when you're actually doing an actual test on it. Then we can move up to a more sophisticated system, and this is actually one of our latest damper test systems here. We actually have partnered with Simplex with their fire alarm panel with a new device that we call the ADC 105. It's the addressable damper controller, and the 105 is to tie it in or correlate it back to the NFPA 105 standard, which is for smoke and fire smoke dampers, a motorized product. So the ADC 105, it's a component, it's a ship loose item, and it can interface with the Simplex panel, and we'll look at that here on the next slide. So here what you're seeing is this is actually a fire smoke damper that's installed in clear plexiglass just for ease of visually seeing what's happening there. To the left-hand side, you're seeing a Belimo actuator, and then below that you see another junction box here. That's going to be the electronic heat sensor or fusible link for the fire smoke damper. So that is standard equipment. You're going to get that all the time on any fire smoke damper. To the right is our new ADC 105 controller box. So as I said, this is a ship loose item. So what would happen in the field is the damper gets installed by the installing contractor, just like they would in any case. And then the ship loose ADC 105 box gets mounted or located near the damper. And then the contractor would just do the same power wire connection and the switch connection into our box. They would do it anyway into that smaller J box, but in this case, they're going to wire into that larger ADC 105 box. So the wiring they do is going to be identical to what they currently do. It's just in a different box. And then of course the ID net card, the address would be set by the Simplex representative. This is pretty much how it's going to look in the field. Now the box can be located. There's really not a particular location. The box could be on the left-hand side. It could be up or down. It's got a 3-foot conduit run. So wherever that facilitates locating it, then they can locate it as they choose. So our ADC 105 box works with 3 of the Simplex panels. These are the ES series, and as you see there, it's kind of a small, medium, and large sizing. So the smaller one can handle up to 250 devices, and then of course it goes all the way up to 2,500 devices on the larger panel. Now, when we say devices, what that really means is it could be a pull station, it could be a duct smoke detector, one that's addressable for the panel, and then as well as a damper. So a device is really just a point in the system. So a damper, so if you had a large facility, let's say with 500 dampers, and you had, a couple hundred other devices, then obviously you're going to pick the panel that facilitates that. If it goes beyond what the panel can handle as far as the number of devices, then they can extend that through extenders. Then the panels just get networked together. So if you had multiple buildings on a property, then you can just basically network them that way as well. So here's an example that we'll look at. Before we play the video, let me just kind of explain what you're looking at here. So this is kind of a face view, just looking into the damper. And so you see the blades are open. Now on the left-hand side, we're just showing you 2 screenshots basically of what the panel would look like. When the damper's open, it's going to have the green lights that you see on the upper left, because obviously the green means it's open, and the bottom is the red lights when the damper goes closed. So we'll go ahead and start the video, and you can see how the damper operates. So we've lost power. The damper just goes to a full closed position. The spring in the motor has basically just allowed it to go fully closed. And then once the power is restored, and this can all be done at the panel. If somebody wants to test the damper, they just do it quickly and easily through the panel. So they've restored power, and then they'd have the green lights back. So again, this is a 24/7 monitoring. So you not only have full monitoring all the time of the damper status, but you also have the quick ability just to test a damper or all the dampers, depending on what you need to do. Now this next video here, let's see, yeah, kind of got started quickly, but let me just explain what's happening. So because this is 24/7 monitoring, the panel knows the status of the damper, because the damper, remember, is fitted with a switch package, and the switches are reporting back to the panel. So if your damper is not fully closing, the panel's going to report that or indicate that. So in this example, you can see there in the center, we basically put in some Cat5 wiring, just bundled it together just to create an object that's there blocking the pathway for the dampers to close. So we'll go ahead and start the video, And you can see what happens when the blade tries to close against an object that's lodged into the damper frame. So as that blade tries to close, of course, this wire, it's really too hard, so the damper can't overcome that. So what would happen is, as you see on the upper left-hand side there, that's sort of a screenshot of the panel, and it shows you that it went to a trouble alarm. So once that blade doesn't make full contact, the panel goes into alarm. It basically can give you a readout of where that damper is located. You can see in the example here, we're saying south quarter damper partially open. So they can assign locations and descriptions just to be able to identify where it is. So as you can see here, it'd be quick and easy to know where the problem is. And so that's the time that you need to get up on a ladder to go investigate. But as long as everything's reporting as normal conditions, then there's no need to have to get up and actually physically be at the damper to check it out. It's all done through the panel. So that's the beauty of the Simplex and ADC 105 interfacing, because now you have a quick, easy way to know damper status. You can test a damper, and it just makes everyone's life easier. So our ADC 105, it is available. If the facility is already using the Simplex panel, they can actually retrofit that. So if dampers need to be connected to the panel, if the building owner sees a benefit in that, they can actually just, well, if they don't have switches on the damper, all they'd have to do is add switches in the field to the damper and or replace the actuator with the built-in switch. And then they'd use our ADC 105 panel, just as you see there on the left. They'd just locate it near the damper, and then they would just run communication wire back to the panel for those dampers. So yes, it could be retrofitted, or obviously if it's a new installation, then you'd have everything come out at one time. So that's one of our latest systems. Again, Ruskin has been the leader in maintaining dampers through various systems. We've had 2 other ones before, but this is sort of the latest and greatest, system that we have available through the Simplex channels.
Hey, Mike, I just want to clarify again. So how many dampers can be wired to a single ADC 105 controller, and how many dampers, how many ADC 105 controllers can be wired to a single Simplex panel?
Yeah, that's a great question, Spencer. For the ADC 105, it's a 1-to-1, so it's 1 per damper. So there's no multiple, or you can't piggyback off another damper. So it's always just a single ADC 105 per damper. And then on the fire alarm panel side, depending on, and sometimes we're not going to know how many devices that are going to be there in the system. So they'll just need to, figure out what how many dampers versus how many detectors or pull stations, and then beyond that, they would just add another panel if they run out of device space on the particular panel. So that's just simply a matter of whoever's handling the Simplex side and knows how many devices are going to be involved, then they kind of work it out from there. So yeah, it's really kind of unlimited on the panel side, because all they do is just keep adding additional panels and networking those if they need to, if it's a really large facility. And with that, I'll turn it back over to Tessa.
Thank you for attending today's webinar. If you have any questions, please contact Emma Barnhart. We will be sending out an email after the meeting concludes with certificates of attendance and a link to next week's webinar registration. That being said, please join us next week on October 14th at 1 p.m. Central Time for our discussion on louver certifications. Thank you again for attending, and we hope you all have a wonderful day.